So for the first example, we are given this problem of a point load having 5 kilonewtons at 1.75 meters from this point, which we will be assigning as point A, and this will be point B, and this will be point C. The hinge will have two support reactions for which we will put a y and ax for horizontal and vertical, and the row will have only cy. And then the first thing to do here would be to find the summation of forces horizontal, which would be equal to 0, right side positive, left side negative, and then as it is the only one, as it is the only one having a horizontal direction, it will be equated to 0. And then we will proceed to Fy is equal to 0, positive, negative, upward and downward. But we are not able to solve this yet because there are two missing reactions that we will be able to find after we use the summation of moment at point A or C. I'll be using point A for this one, and then positive, negative for clockwise and counterclockwise, and then we will have 5 kilonewtons times 1.75 meters is equal to cy times 3, because 5 kilonewtons is rotating clockwise and cy is rotating counterclockwise. Therefore, this is the outcome. And then we will be dividing both sides by 3 meters to isolate cy. So we will have cy is equal to 5 kn times 1.75 meters divided by 3 meters. We'll be cancelling out that unit, and then we will be using a calculator to solve for the answer, which we will have simply 2.9167 kilonewtons. Now we are able to solve for a y by simply transposing cy here. We will be having the equation of ay is equal to 5 kn minus 2.9167 kn, and then ay is simply 2.0833 kilonewtons. Okay, now that we have found all our support reactions, we can now proceed to finding the beam, shear, and moment. So first things first, we will be imagining if there is a cut. There are 2 points that cut the beam, and this will be point 1 and this will be point 2. What this simply is to what do you call that? Represent the distance of this from here to here to cut A. I don't know. So this will be x, and the second will be x as well. So we will be assigning this as x1 and this will be x2. So first things first, we have to try and assume the value of x. So right now 0 would be less than x, and then x would be less than 1.75. As you can see here, it is less than 1.75 and greater than 0. And then the second cut will be greater than 1.75, but it is also less than 3 meters. And this is how we'll proceed to the next step, which is to draw a free body diagram for this and this. So first things first, we have to put AY here, and then there would be a constant, or should I say, I think that's constant, yeah. Constant's the right word. This has a constant shear going downwards and a moment force going counterclockwise. And then we'll be solving for the X. No, for the support reactions, I guess. No. I got it wrong. We will be solving for V and M. So V would be equal to AY, since they're the only forces there. So we know that AY is 2.0833. So that will be the answer. And then next we have moment. And it's easy to find moment too, because we only have AY and X to equate to. So moment will be equal to AY times X. Or simply 2.0833 X. And then in here, we are able to go and proceed to the second free body diagram of ours, which will be AY, and now with the point load of 5 kilonewtons, with the distance being 1.75 meters, and then the shear motion and the moment motion. So to find the shear first, we will be using the summation of forces Y. AY is equal to 5 kilonewtons plus V. And then we all know what AY is and V, so we can easily solve it. But we are not looking for AY, so we'll be transposing this equation to have V is equal to AY minus 5kn. And then we will have the answer of V being negative 2.9167 kilonewtons. And then we will have a moment. We will be using the summation of moment. We have AY. Do we have AY? I'm not so sure, honestly. Let me check the notes first. Okay, so I'm back. I have reviewed the notes, and then we will be continuing the solving of the problem. So first things first. So moment at this point here. This is a clockwise direction, so that will be a positive times x, which is the distance. And this one here is a counterclockwise, so it will be minus 5kn times the distance of this one. This is the distance here, not this. The distance here from here to this point. So that will be x minus 1.75, and then this is the m for segment AC. I don't even know that I won't be using those terms anymore. So here we have the V and then the moment for these two segments. So with using this, we are now able to graph or draw the diagram of shear and moment. So I will be clearing this. Shrinking it for a moment, so I will have space to draw for my diagram. So the diagram will look like this typically, like that. This is where the point load is, and this is where the hinge and the roller is A, B, and C. This has a measurement of 1.75 and this has a measurement of 3 meters. So onward, this would be the shear and this would be the moment. So in shear, we'll be using this one. So that is 2.0833. Simple as that. And then this in the second portion, negative, this one below, not this, which is negative 2.9167. And then for the moment, we'll be using our calculator, find the table function, or in the menu find the table format, I guess, and then it will be asking for an f of x, where you will type the moment. So in this, we have the moment of 2.0833 times x. Make sure to add the x, and then we'll be typing in the starting number, which is 0, and then next would be the end value, which is 1.75. It will also be asking for a step in which I will be putting 0.25 just for this problem. The step is there for you to find the increments of the distances. It's up to you how much the step will be, but in this problem, 0.25 is enough. And then you press equal, where you will be able to see that in this point there is a 3.6457 kilonewton meters, like that, an inclined plane. And then using the second one and these starting and end values here, the calculator, by inputting it, that is 2.0833x minus 5 times x minus 1.75, we will be having the answer. Wait, no, I have to put the start and end range first. And there we have it. We have the answer of 0.0001, but the idea is that it's close to 0, so it falls back to 0 in this problem. And that is the example number 1.